after these two slides. Yep. All right. So lesson 2 is mostly just interpreting functions. Okay. So we're given a function, and then we're asked, hey, what does this part of it mean? Okay. And so we did a little bit of that yesterday when we were analyzing what a variable represented, and then we were building the equation. In order to build the equation, we kind of have to know what each part means. And so we're doing that in reverse. Okay? And we still want to think along the lines of our slope-intercept point. That's our model. Okay? So slope represents rate of change. So whenever we have something that is the slope, we need to think of that in context of change, of rate of change. Whenever we have a constant, we want to think of that in terms of starting points. Okay? Where would we begin? So in this situation, we've got the amount of money that farmers in Massachusetts paid to maintain their crops between 1991 and 2008 is modeled by the function P of t equals 3.53t plus 100, where P of t is the amount of money the farmers paid in millions of dollars, and t is the number of years after 1991. So what does 3.53 mean in this context? And before we even look at the options, one of which I have duplicated, so we can ignore that because that's on their place, we want to see and kind of come up with our own idea of what it might mean, and then see which of these fits best. So what part of my equation does 3.53 even represent? The terms of slope-intercept point. M, our slope, our rate of change. 3.53 represents our rate of change. So any answers that we look at need to represent some rate of change over time, from year to year, because that's what our T represents. So from year to year, something has to change. Okay? So when we look at A, the cost for maintaining crops was $3.53 million in 1991. I swear, I'm going to yell at that much better. Or you all are just like, in on it swear. Does that represent a rate of change? The saying that the cost to maintain the crops was $3.5 million, is that a rate of change?
Yeah, because no.
Not in that sense. It just says, hey, this was the cost. Boom. That doesn't represent a rate of change, does it? No. Okay. C, the cost for maintaining crops increased a total of $3.53 million between 1991 and 2008. Does that represent change? Not from year to year. It represents over the whole time frame, but not from year to year. And remember, our slope is going to be from year to year, from whatever increment on as we go through. Okay? So probably not going to be C because of that total. The cost for maintaining crops increased by $3.53 million each year between 1991 and 2008. Does that represent my rate of change? Yeah, because of that each year. Each year is our rate of change. So the 3.53 million is the amount it increased each year. Now part B, so we want to look at the other part. 100. What part of my equation is the 100? The B, which represents the what? The y-intercept. So the 100 is our y-intercept. And again, y-intercept is usually our starting point. So we want to think of it in context of our starting point. So we're going to have to kind of come up with this on our own. But what would 100 represent in this specific context? Say it again. From where it parts. So where it starts, can we be a little bit more specific? add in some specific context. What amount of money? When?
Years after 1991.
That's what P of T is. So we could solve for any year. But you're getting close. Okay, when is the initial amount of money? Let's start. 1991. Starting is in 1991. So 100 is our starting point. $100 million in 1991. Think of this. Our formal definition of a y-intercept is when x equals 0. Well, in this case, our x is actually a t, okay? Because that's our independent variable, our input. So when t equals 0. When t equals 0, what year is it? 0 years after 1991. So when t equals 0, we're dealing with the year 1991. How much money was spent in 1991? $100 million. So what does the 100 mean? The cost in 1991. The amount of money spent in 1991. So understanding what the slope means in this context and understanding what the y-intercept means in this context. So it's very similar to what we did yesterday, but just kind of on the back end. Hey, here's an equation. What does this mean? What does this mean? Versus pulling out that information and having to write your own equation. On the flip side, if you had to write an equation, they would say, in 1991, the farmer spent $100 million. And that cost increased by $3.53 million each year. Write an equation that models this function, and then you would end up here. But now we're just switching it the other way around. Here's an equation, tell me what it means. Versus here's information, write an equation. Alice fills up the gas tank of her car before going on a long drive. We have the equation G equals 12 minus M over 32. That models the amount of gas, G in gallons, in Alice's car, which she has driven M miles. What is the meaning of 32 in this equation? So is that part of my slope or is that part of my constant? It's part of my slope, right? Because my coefficient is 1 over 32. That's part of my slope. So that's a rate of change. Rate of change. So which of these scenarios represents a rate of change? Which of those options represents a rate of change? Okay. A represents a rate of change. Okay. Alice uses 32 gallons of gas per mile. Okay. Does B represent a rate of change? It can hold 32 gallons? No, because the gas tank's not going to change size, right? So we definitely know it's not B. Okay. Alice can drive 32 miles on a tank of gas. Does that represent a rate of change? No, that's just the range, how far she can go. So that's not a rate of change. Alice's car can travel 32 miles to the gallon. Does that represent a rate of change? Yeah, it does. Alice's car can travel 32 miles to the gallon. So yeah, I mean, that represents a rate of change. Okay, so which of these makes more sense? That she uses 32 gallons of gas every time she drives 1 mile, or that she can go 32 miles for every 1 gallon of gas? D. If it was A, our model would be 12 minus 32M. She uses up 32 gallons for every single mile. But with the model M over 32, it takes 32 miles before she uses up 1 gallon of gas. Okay? So Alice's car can travel 32 miles to the gallon. So we had two that kind of represented a rate of change, but only one of them makes sense based on how the model's written. Okay? So now, let's look at part B. Part B says, what is the meaning of 12?
much gas?
How big her tank is. She fills it up, and then we've got that expression. So remember, if we take 12 m over 32, and she drives 32 miles, that means she's using up 1 gallon of gas, which we're taking away from 12. She drove 64 miles. That's 2 gallons of gas. We're taking away 2 from 12. So as we continue to drive, we're taking more away from this total. Our constant, our starting point, what she starts with. She starts with 12 gallons of gas in the tank. Okay? So when you're asked to interpret a linear equation, don't overthink it. The starting point, or is it a rate of change? And then read through the options to see which one makes the most sense. Is it a rate of change? When you're dealing with these types of questions, there's not going to be a whole lot of work to them. So when you're doing the interpreting linear equations assignment on Khan Academy, so you'll just write the assignment, what level you're starting at, what level you're ending at. Okay, that's kind of it for those. But for the other types of ones, there will be some work to make sure you show those. Okay. Any questions, comments, concerns? All right. Cool. So do you have the